Hi, I'm Samuel Recine, Vice President of Strategic Partnerships at Matrox.
I'm Jean Lapierre, a Senior Director of Advanced Technologies for Matrox.
Mike Bergeron, Product Management at Panasonic.
I'm Thomas True, Senior Applied Engineer for Professional Video at NVIDIA.
I'm John Myatt, CTO and Product Manager at Imagine Communications.
Yeah, well, I'd like to thank everybody for coming, and really thrilled that we could have such a good panel of experts in 2110, going back to the beginning. So let's start with the beginnings, like where we started and what we got to now, because I mean I think we've seen the deployments of where this technology is being used have changed quite a bit in the last few years, and really like here now, what are some things that we're now seeing for the first time?
I think you were at the beginnings.
Oh yeah, I was there at the birthday. So 2110 is a process that's been going on for about 10 years now as an industry. I was the editor of SMPTE 2110 through this process, which was a pretty interesting experience. SMPTE 2110 was created by a drafting group that had at the peak about 200 participants, and sometimes 30, 40 people would show up at the meetings and have opinions, which is, people who just listen, that's one thing, but there's 30 or 40 people who had real opinions that were sometimes very strong opinions. So the process really spanned all the facets of the industry, everything from post-production, television networks, shooters, Hollywood, you name it, were involved in creating a standard that could be one standard that would meet everybody's needs. And one of the things we talked about early on is, should we use a codec? These network links are kind of expensive. 10 gig at the time was still spendy. And we made a decision that said, no, if you send the real pixels, then no one's going to complain about your codec. They're going to get the pixels that the camera shot or the pixels that show up with the switcher, and nobody has any complaints. And that's true to this day in the core 2110 systems. And it's been a feature that, you never are worried about picture degradation, how many cycles you go through, this, that. We're building, originally very large systems. The first deployments of 2110 tended to be very large systems because they were systems that were trying to be beyond the scalability of SDI matrices. If you build an SDI router bigger than about 1,000 outputs or 1,000 inputs, it gets really complicated what you have to do. So those were the systems that 2110 first launched in. But the standard was designed to work at any scale, that the IT industry could develop equipment for. And most IP and IT deployments are actually very small. So I'm really grateful that now we see, even at the lowest end or smallest deployments, we're able to use the same 2110 technology, whether you're directly connecting two devices together or you're building the system of all systems.
I remember when we were in the early days where we show up and connect everything together and make sure everything is working and it's according to the spec and things like this, having discussions. I really appreciate the fact that you guys did a really good job, saying, well, if you're going to do this, this is how you need to do it type thing. Mm-hmm. So you could read the spec and show up, and then it would it would work because it was clear that if you were doing YUV422, this is how you need to pack things, this is how things need to be put together and everything. Also appreciated the fact that it didn't limit itself to, I guess because you had so many people involved in that group, it covers how to do RGB, it covers how to do 422, it covers how to do pretty much anything, any size. One of the things that was also interesting is doing a demonstration and explaining to people that, you can actually mix all these different formats, whether it's HD or SD or UHD, and put all of that on the same network, right? Because typically, those SDI system would be like one format, usually, right? Yeah. And that was cool.
Well, no, we took advantage of that. I mean, that was one of the exciting things when we developed Kairos, is because because it was a software-based switching platform or mixer, whatever we want to call it. there was no system format. Like anything had to have a system. You had to have the system format. Everything would have to be converted to conform to that, and that would have to be the fattest signal. So and even now, when people are looking at, they want to have a 4K production, they think everything needs to be 4K, and then it blows up the complexity. And I think that's where we're starting to see some of the advantage in that, to be able to include some of those higher formats without blowing up the cost and complexity of the system.
Oh, absolutely. And we see more and more customers that they want to do 4K sometime for some shows.
Mm-hmm.
But the ability to now design equipment that's thoroughly flexible, and you can have HD, you can have 1080p, you can have UHD, and you can not just intermix them, meaning the morning show is still HD, but that special on Saturday is UHD, which we see a lot of in the mobile industry especially. But you can have productions, individual productions, where the studio cameras are 4K, but some of the specialty cameras are 1080p. The remotes maybe come in 1080i, and you mix it all in the same show, and the equipment knows how to sort it out, because in the control, in the NMOS layer, everything says what it is, and that way you can figure it out and the show can get produced.
I think that, so go ahead.
I was just going to add, that's also helping SMPTE 2110 to move beyond traditional broadcast, like we're seeing it in virtual production, where you, on the top of wanting to do 10-bit or 12-bit RGB, they also want to do all these weird non-standard video resolutions, and 2110 just makes that easy.
One of the things that was good about 2110 is the scope of it was just the right size. It got enough accomplished to deal with a migration to IP, but it allowed other forums to discuss the asset discovery and registration and other specifications that were added later to complete the system could evolve not at in the same timeline, and this was a contributing element to the success of 2110 is the ability to keep layering on it afterwards.
Yeah, that was a purposeful decision. There was a joint task force on network media that was a kind of consortium of all the different standard groups, and we very purposefully kind of divided up the work among the organizations so that you got the right people in the right meetings that represented all the different viewpoints, and those things were able to proceed in parallel. So at the end, we had a transport standard from SMPTE, a control plane standard through AMWA, we had other documents through VSF, and it all came together, timed together, almost like we actually managed it, because we did.
Yeah, well, I think early on there was also a concern that you weren't going to be able to teach. When this discussion came up all the time, that either broadcast engineers were going to have to learn networking, or network engineers were going to have to learn broadcasting, and it was going to be too much, and the skill set was going to be there. But I think there's been a lot of developments that have kind of made the system easier to configure, so that panic about getting the skill sets up never really materialized in my view. I mean, maybe in some of the early deployments, I imagine at a small scale it did, but I'm not hearing that kind of anxiety anymore.
Yeah, I think there are two things met. The 2110 specific stuff, most products and solutions have ways to make that stuff happen and simple enough. But equally, this putting the video on IP was the last part of all the other infrastructure going to IP. Mm-hmm. So the automation systems, tally systems, storage arrays, anybody that's got more than one editor has an IP storage system already tying those together, right? So everything else in the studio, everything else in the production environment already is IP networked. Moving the video there is great, and it's sort of the last piece, right? So people already had to know how to work IP networks if they were going to build a facility, large or small.
Then what we were showing today, and we're seeing this across the industry, is, I mean, if you're just looking at a chain camera, a studio camera, you've got this big rack device that's just a bunch of interconnects on it. They're SDI interconnects, serial interconnects, and all that stuff is on the network. So as we, so we're kind of doing it twice. right? So we're getting it onto the network, and then we're also building all these other interconnects. So as we get everything in there, we can start to remove hardware.
Yeah.
And I think that's something we're looking forward to in the years to come.
Yeah, we're starting to see that type thing. So we're starting to see like LED walls that would have a controller that's native, SMPTE 2110. So that's great. I mean, when we got started, we were talking about this. You had to put a converter in front of all of those devices. But now we're seeing that. We're seeing those devices that are natively 2110, whether they're the cameras or the walls or they're the monitors. So that helps a lot as well.
Right. Yeah, it can do more work. Yeah. I mean, because you're seeing a lot of these screen processors. Most of what they're doing is just managing, a string of display ports and how you're going to tile them. Where all that can be done in software.
It's amazing how many SMPTE 2110 systems today are already a mix of previous signals being converted to 2110 and native 2110. So it's already quite mixed.
Well, when you were looking at this, you never would have anticipated esports broadcasting.
Well, my children are employed in the gaming industry, so actually I was quite tuned into that. But it's really the variety of television production is always increasing. Back in the 70s, television was 3 big studio cameras and an analog switcher at a TV station. Now, television is just a word we use to describe an incredible variety of things. If you look on YouTube, you can find hundreds of different streamers on really tiny topics making incredibly high-quality shows with really nice equipment that they put together in their studio, and they do it all, and a lot of it uses 2110 or uses other, IT-based technologies. And that's what we've enabled, is getting television out of the prison of being stuck in a TV studio and into everybody can do it. And this feeds into all kinds of adjacent markets. We do a lot of work together in houses of worship where Kairos and a couple of gateways and things, and pretty soon you've got a really beautiful, first-class, high-quality production going. And you couldn't do that with the old stuff, right?
Yeah, well, I mean, and also corporate communications, they're always trying to up their production value because they've got to compete with what people can do with their home gear, and make something that people want to watch. And also I think during the pandemic, the better the production value of your teleconference, the less Zoom fatigue.
Right, and I think the corporate market is only beginning to really realize the power of Kairos and what it can do in terms of multi-room productions and the ability to, separate and divide and conquer things. It's so much easier to do flexible, large-scale corporate productions in Kairos than it is to take a bunch of small traditional switchers and attempt to do the same thing.
So there's definitely a need for this technology and a growth in trying to deliver production value in all kinds of markets that we hadn't been thinking about maybe 10 years ago. But what do we need to do, and what are we doing now to get these systems down in scale and reduce the complexity that they can be deployed in more of these situations?
Sure, making it accessible. That's a great area of improvement year after year. We've been seeing people assembling smaller purpose-built systems. You can actually connect, as John was saying earlier, devices directly to each other and leverage the power of what's in the standards. Or now with NMOS, being able to build small systems where things sort of just find each other and start to work. Really, system compatibility, equipment compatibility, and ease of setting it up are what make it accessible to smaller applications where the skill set may not be there to build a larger, more complicated system. And we've definitely gotten to the point where you can build smaller systems.
I mean, using the IT technologies at the core gives you the advantage that you can leverage all the different products made by the IT industry for the IT industry, where they aren't limiting their thinking to television. Now, this enabled us to use these giant data center switches to do the really huge 2110 networks, but at the same time, it enables us to operate all the way at the other end of the spectrum too. So NVIDIA, for example, makes a little switch that it has all the same features as the giant switches, but it's little. And it has a right number of ports for a small project. So thank you for that.
Oh,
That's like enables all kinds of small projects to have a right-sized switch. And that's the power of the IT industry, is that, you know, perhaps others might make those too, but the NVIDIA one works good. And it's really used, you know, enabled customers to make small projects simply and straightforwardly that operate at these kind of, you know, line feeds and do 4K and have the right timing and everything. You can direct connect as well. We do a lot of projects together where we just direct connect Kairos and SMP, but then we have projects that say, okay, now I want to add a second this or a second that or a few more cameras, and okay, put that together with a small switch. You've taken that one baby step into a really powerful system. And then you add a control plane on top of that, and you're able to, you know, route things instead of just kind of hard coding the assignments, and away you go. You can grow the system as your production needs increase.
So in terms of being able to enable smaller setup and as you were saying, less skilled required to build this type thing, the NMOS is really, like I remember in the early days of NMOS talking to people at trade show explaining what that does for them type thing. And when you think of a smaller system, it's like you put all these devices on your network, a few of them, because you're building something small. And you know, it's really easy to you add your little controller, and it's going to tell you, here's all your sources, here's all your destination, here's your monitors, your cameras, and everything. Click, click, click. You just up and go. It takes minutes, not hours or months.
I can't imagine getting into production rental without that.
Correct.
I mean, if you've got systems that you're tearing down, going to get into concert touring and things like that, we need to have that. That's exactly the kind of tools we need to be able to get these things kind of self-configure.
Yeah, and when they crafted NMOS, a lot of people think, NMOS, you need that server, you need to put an extra box so that everybody registers. But it's really designed to, if I put 5 or 6 devices on the network, I don't need that extra server. It just discovers everything. You can still do the same thing as if you had the bigger system with the server. Smaller scale, there's some pieces you don't need it, and it still works. It's designed really, really well for that.
Another tool for smaller systems is a lot of purpose-built equipment. A lot of the original SMPTE 2110 equipment was really purpose-built for signal a certain type. With smaller systems, if you want to use just regular PCs to do a bunch of things that replace some more, purpose-built larger equipment, the second, third, and fourth wave SMPTE 2110 products that have emerged now support the ability to bring PCs and weird resolutions and these types of sources into a production as well very easily. So just the full gamut of IT tools being a part of that system is great flexibility as well.
Yeah, I think that opens it up to more people on the artistic side, where we've got a system over in Brooklyn where they've got like guest artists who come in. They plug their laptop into the system, and they're driving the graphical system real time as part of the performance, and that's a system where it's just a 100 gig line, front of the house, back of the house, and for inputs and outputs.
Yeah. Borrowing an example from the COVID years, that laptop example that you just provided, piping a Zoom call through your Kairos at the same time as a lot of other things are going through it. It's a convenience to be able to just grab it and add it as one of the many sources.
Yeah, the teleconference just becomes a node.
Yeah, right.
The ability to use COTS coming off the shelf hardware, COTS hardware, is really lowered the barrier of entry into like a 2110 workflow.
No, well, we're seeing more people getting into the game too, on that. Like, so now you have
exactly.
switchers, depending on the budget and the level of risk that people are willing to take.
And what I'm seeing is someone who works more on the developer side, working with developers. I have developers coming to me almost every day now with oh, we need to talk 2110 now. We've been doing SDI, like color grading and applications like that. We've been doing SDI forever, but now we need to be able to plug into this 2110 workflow. How do we get started? What pieces do we need? I'm seeing that almost every day now.
Yeah, I think early on with 2110, a lot of solutions were, like FPGA based, and you needed this specialized hardware, but it was always designed to enable software to be able to do work and everything. And now what we're seeing is more and more of that software actually, being out there and being in use type thing. At the beginning, it was a little less, and now you're seeing more and more in that. And then you see these contribution from software, pure software, with just a NIC card in the system and things like that. So that's enabling also this smaller environment. And
it's really enabled the software, what we call the software-defined workflow.
So the future's bright. There's a lot of different things we've been looking at, and of course, once everything is in customers' hands, then you start to get like, well, can we do this? Can we do that? So looking out 3-5 years, what are some things that people might not be imagining right now that they're going to be able to do?
Yeah. We haven't talked about cloud today, and cloud's a big thing. Now, cloud's not for every purpose, right? There's places where its economics make a lot of sense. There's places where cloud gives you some other operational advantages. So what we're going to see going forward is every business and every production finding its right balance of ground and cloud. Cameras probably going to be on the ground forever because that's kind of where the talent is, right? But do you put your switcher in the cloud eventually? Depends on your economics. It depends on what you do, how many shows, how it's tied together. The cloud's not free. That's kind of its biggest problem. So what we're going to see going forward, I think, over the next couple of years is 1,000 different models of what's in the ground and what's on the cloud and how it makes sense. And that's just driven by local situation. Everybody's economics and everybody's needs are a little different. But we're going to see this constant, flux of some things virtualized, some things physical. And what enables that is the things we've done on software-defined workflows and software-defined signal flows, which really transcend whether it's running on the ground or cloud.
Yeah, probably another major evolution in the next few years is all extension and switching in facilities for the purpose of AV distribution, whether that's HDMI or HD-based or other things, will probably start to migrate towards IP-based methodology, and the standards really support that migration. So, right now 2110 is largely used in live applications, live studio equipment, but even for facility-wide distribution and connecting that in and out of the live stuff as well, this is a major next step.
In terms of markets, where are we? I mean, so now we're already seeing house of worship, esports, some universities, in corporate communications. What anything else? I mean, I haven't seen a lot of like operation centers or medical or.
We're seeing it.
Yep, go ahead.
Yeah, because with SC2110 we can get rid of all these dongles that convert from HDMI to 2110, and we're getting the SDI or the SMPTE 2110 native devices. We're seeing like markets such as like visual simulation and other like large venue visualization, borderline pro AV markets going with 2110 now to get rid of the fiber optic extenders that convert the different signals, because those are typical points of failure and they're like not so high quality devices. So we're looking at other industries trying to get rid of all of those little devices and just use network video over IP SMPTE 2110.
If we look at where 2110 began, it was keep everything we like about SDI and move it to IP. And the impetus for moving to IP was, many more nodes under management, no limit to distance. So all of the advantages of IP, I want to get that, but I want to keep everything I had with SDI. But SDI isn't the only signal type in the market. There's HDMI, there's other things. So, opening up SMPTE 2110, building on that and adding support for those other types of signals will everyone wants the same advantages, infinite number of nodes under management, infinite distance, but keep the properties of those signals that I need for my application.
Right, and particularly HDMI is a great use case for, we all use it, we use it every day, we use it in a million things. And 2110 can carry it, but it's just now the standards and everything coming together, particularly in the IPMX work that many of us are involved in, is really geared around how do we solve the HDMI use case really well, including EDID negotiation and some of the other things that happen in the signaling plane that are unique to HDMI.
Yeah, so
But,
since we're speaking about future trends, there's protected content, there's security, so being able to load private keys into devices to secure them, and giving the users the power to have systems that they can trust, that permissions management about who can see what signal, these types of things. These are
Right.
You
manage screens in your local
immediate
sports
evolutions.
bar.
Yeah, exactly.
And for me, I guess where I see it going is, with 2110 has been used a lot, like in uncompressed world, like you were mentioning. Nobody's gonna complain that the bit got mangled if you're not touching the bits and everything. But and then moving to smaller system, less expensive system, getting more people access to this technology. As you were mentioning, people are producing very high quality show with 2110 sometimes, but other alternative type thing. Being able to move to a network that's like a gigabit instead of 10 or 25 gigabit, so some compression, standardizing around something, which is going to be a challenge, but I mean, we have 5 years, so.
Yeah. Okay, I gave you 5. You're to take the full 5.
You gave me 5 years, so. But I mean, we already see, like it's possible to move that HDMI 4K RGB 444 signal and put it up on screen, and there is technology out there that can do that very effectively and lower the size of the pipe that's required.
Right.
And that gives you two advantages. It gives you the advantage, of course, of being able to use a smaller pipe, but even if you have access to that bigger pipe, you can now move many things. Right. And so problems that we encounter today when we're doing 4K and stuff like that is, if you want to bring that into a multi-viewer, that's a lot of bits to bring into a multi-viewer, and that's expensive. So being able to have something that's compressed to bring it in, once it's in, fantastic GPU and NVIDIA has no problem decompressing that and putting lots of stuff on the screen for you, but you have to get it through that pipe.
Well, I sort of see it as there's two ways you can build an entry level production system for the masses. I mean, you can build something that you can just get something out the door that's a technological dead end, and it's really cool, and then it goes away and it gets replaced 100% by something else. Or you can work within standards and build something that's that even for somebody at that level, it's still got a future.
Yeah, the minute you open the door to topics like codecs, like what John was saying, the strength of how SMPTE 2110 was developed really shines, because as somebody said earlier, you could run SMPTE 2110 in software. It doesn't have to be on dedicated processing. And what that means is a new category of product can emerge, the category where you can convert things that you need for your 2110 environment. So being able to convert from codec A to codec B, or from uncompressed to compressed, or from protocol A to protocol B. 2110 doesn't break any of that. It allows you to start to federate the other signal types that you want, and even protocols that you want. You probably won't see two competing protocols ever create a bridge between each other. So proprietary protocol A won't create a way to connect
proprietary protocols
protocol
are never
B.
going to go away.
but you can probably do protocol A to a standard to protocol B, because that standard belongs to everyone.
Well, it's a lot more convenient than taking a picture of your screen with your cell phone.
Absolutely.
And you were talking about HDMI type thing. So I envision, for me anyway, it's like coming out of the laptop. If you want to go use your laptop to generate a signal for your production, we're just going to come out the IP spigot instead of the HDMI spigot, right? So.
Yep.
that's here today actually. So
Yeah,
we're getting
let's
there.
do that.
Yeah,
we're getting there.
More than that. Well, I think that's probably a great place to stop because I'm not going to give you 10 years. Right. Well, thanks everybody for coming. I hope we get a chance to do this again sometime.
Thanks,
Thank you very much.
Be part of it.